Hi there, this lesson is on ratio tables. We're going to be working with ratio tables relating quantities with whole number measurements, finding missing values in the tables. So we're also going to be reasoning about tables of equivalent ratios. You can see that the standard 6.rp.1.3 has many components, so we're only working with one of several components in this lesson. We're going to be working in your workbook pages 40 through 42. I would like for you guys to have those out and ready. You will be taking notes, especially in the margins and on the actual workbook pages. I also would like for you to get those lined post-it notes out that you should have. If you cannot find your lined post-it notes, any type of post-it note will be fine because you're not going to have enough room to do everything on this lesson, so you may need to use your post-its so you could just attach them to your sheets. You also need to make sure that you complete this work with a pencil and not a pen. So let's begin. All right, so looking at the first page, which is page 40, what I've drawn an arrow to here is it says soda on the top line, juice on the bottom line, and this is set up as a ratio table. A ratio table is a table that uses columns, now your columns go up and down, that are filled with pairs of numbers that have the same ratio. For instance, in this ratio table, if I look at my first numbers right here, the 1 and the 3, it's saying that they are equivalent. Equivalent meaning equal, okay, to the 2/6 and to the 3/9. So, for example, if I write 2/6, which is my middle ratio, right over here, and I simplify it, if I were to divide both the top number and the bottom number by 2, because that's the greatest common factor, I would end up getting 1/3, which is that first ratio. The same thing goes with 3/9. Now I grab the 3/9 from over here. If I were to simplify this guy, the largest factor that they have in common would be 3. When I simplify this, I end up getting 1/3, which you'll notice is the same thing as what we started out with at the beginning. So since all three of those ratios are equivalent, meaning equal, then they express or they show the same relationship between the quantities. So now that we have defined what a ratio table is, let's see how we're going to be using them in our lesson today. So if you look at example 1, it says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So in this first example, if you go back to the word problem, it says that you mix 6 drops of yellow food coloring, and then you're comparing it to 1 cup of white icing. So if you look at the table that they created for you right over here, the one that I'm putting a box around now, you'll notice that they labeled the top of the table drops of yellow, which represents the drops of yellow food coloring, and then the cups of icing is the second part, so it's this part right here, since that represents from the word problem right over here, 1 cup of white icing. Let me take my arrows away. So when you're setting up a ratio table, because ratios use words, that's why they're including these words over here in this table. So to set up your own ratio table, because you will need to in some of the examples that you'll have, you're going to just make a basic rectangle. So I would like for you to go ahead and do this on the left side of your paper like I have shown here in black. Use the lines, especially when you're using notebook paper, use the lines on that notebook paper to help you set up your boxes to make it look neater. The lines are there for a purpose. It's to use them to line our stuff up. So you can see here that I went ahead and titled my rows. So I've got my drops of yellow on the top, cups of white on the bottom. I'm going to draw my vertical line. If I can get that in there right. Too big. Okay, that's better. I'm going to draw one more line over here and a horizontal one going across. So from our word problem, so we're looking at the 6 drops of yellow right over here. that's going to be my first number that I'm putting at the top next to drops of yellow. And we're comparing it to our 1 cup of white icing, and I got the 1 cup of white icing from this part right over here. So now the word problem is saying, and let me take away those things here. So what our word problem is asking is, how much yellow food coloring should you mix with 5 cups of white icing? So if you go back to your table over here, so we're trying to figure out how much yellow we need. So that's the part that we're asking ourselves. That's our question mark when we're using 5 cups of icing. So once you set up your table, the easiest way, or the way that I like to do this, is I ask myself, well, I look at the first number, which is my bottom number. This is the part that's complete. I've got 2 numbers and they're both on the bottom. So I ask myself, well, what do I do to 1 to get to 5? Since the numbers are getting bigger, what you're doing is you're multiplying, and the number that you're multiplying by is 5. So therefore, what you do to one number, you have to do to the other. So if you look at the top, what do you do to 6 to get whatever missing number? You'd have to say times 5, because you want to make sure that you're consistent with both the top and the bottom. Since I multiplied the bottom by 5, I must multiply the top by 5. So 6 times 5 ends up giving me 30, and that's how we get our answer of 30 for this problem. So if I take away my question mark and I put in my 30, now remember, when you're going through and answering the final question, it's asking us how many drops of yellow we need. You really need 30 drops of yellow food coloring to 5 cups of icing. So let's look at example number 2. Example number 2 is pretty interesting. If you guys ever watched the hot dog eating contest on the 4th of July, Joey Chestnut has won like hot dog eating contests for many, many years. I can't remember if he won this past year, but I believe he did. And the number of hot dogs he could eat, oh, it's like grossly disgusting. But anyway, going on. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If you guys don't believe me, Google him. If he ate at a constant rate, that means he didn't change his pace, he kept the same pace. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. Okay, so on this one, set up a little bit different. So what we know here is we know that he ate 66 hot dogs in 2 minutes. Let me get my whole thing in here. In 12 minutes, excuse me. I said 2, but I meant 12. So that's going to be our ratio part. So over, if you look at your table here, so going back, if you look at the table that I have drawn here, I've erased some of the numbers that were already there just to show you how you would go from one to the other. So now the 66 came, this 66 right over here came from over here, and this 12 came from right over here. Okay, so we were setting that up with 66 over 12. That's our ratio. Now the question says, determine how many hot dogs he ate every 2 minutes. So really what you're wanting to do is you want to figure out, well, if I've got 12 minutes here, I want to get to 2 minutes. Now I know your ratio table has a third box in there. Sometimes it's not necessary to use that in-between box. There will be an example later on in this lesson where you will need that middle box, but I'm just going to show you simplified version because really this is all that you need to do. So you're going to ask yourself the same question. What do you do to 6 to get 2? Since your number is getting smaller, it means you're going to divide. You end up dividing by 6. 12 divided by 6 gives you 2. So what you do to one number, you have to do to the other. So I'm going to take my 66 and divide that by 6 as well. When I do that, I get 11. So the answer to this question is Joey Chestnut's going to end up eating 11 hot dogs in 2 minutes, or he eats about 11 hot dogs in 2 minutes. All right, so I want to see what you guys can do now. If you look at examples A and B on the got-its, I want you to go ahead and fill in and figure out what the missing number is in the tables. Now, if you look at example B right now, you can see that it's giving you that middle column right over here. You can just skip that middle column for now and just go straight from what do you do to 16 to get to 4, and therefore you can do the same thing to the other one. So go ahead and pause your video now and figure out what the answer is, and then you can push play. All right, let's see what you guys came up with. So with our top one, a patient receives 1 liter of IV fluids every 8 hours. At that rate, find how many hours it will take to receive 4 liters of IV fluids. Well, since I've got a 1 liter to an 8 hours, here's my ratio, 1/8. So what do I do to 1 to get 4? And I got the 4 from right over here where my box is. I divide, since my number is getting smaller, by 4. So therefore, I'm going to divide the 8 by 4, giving me 2. So the correct answer for the top one ends up being 2 hours. On part B, it says, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberry. So that 12 cups of sugar and the 16 cups of cranberry, right here is our ratio, 12/16. It wants to know how much sugar is needed for 4 cups of cranberry. So that's where they gave that 4 right over there. So what do you do to 16 to get to 4? You divide by 4. So therefore, you're going to take your 12 and divide that by 4. 12 divided by 4 gives you 3. So what you end up needing is 3 cups of sugar. So let's go ahead and look at page 41. Now, what we've been doing by multiplying or dividing two related quantities is called scaling. Sometimes, however, you have to scale back or scale forward in order to find an equivalent ratio. Now, we've already done a little bit of this. For example, in some of the problems that we've had to lessons previous to this one, you've had to figure out something along the lines of maybe something is $9 for 3 of something. Let's say $9 for 3 little personal pizzas. And it might be asking, well, how much money is it going to cost for 4 pizzas? So what ends up happening is if you're trying to find equivalent ratios or equivalent rates, here you can't do anything to 3 to get to 4 evenly. Since the number gets bigger, you're basically going to be multiplying by some number. So it doesn't work out pretty. So what you end up having to do is you end up scaling down, meaning you can figure out how much 1 pizza would cost. So if we put a 1 here, and I'm just using P for pizza, to go from 3 to 1, you would divide by 3. To go from 9 to something, you would divide by 3, only because we divided by 3 here, and you get $3 for 1 pizza. Well, then we know that we wanted 4 pizzas. So what do you do to 1 to get to 4? You multiply by 4. Therefore, we do the same thing to the top, multiply by 4. So therefore, 4 pizzas would end up costing $12. So that basically what we did is what you're going to be doing today using a table. So it's really not that bad. Okay, so look at question number 3 or example number 3. It says cans of corn are on sale at 10 for $4. Find the cost for 15 cans. All right, so what we know here is we've got 10 cans of corn for $4. That is our rate, or our ratio, excuse me. So we've got our cans of corn on top, cost in dollars on the bottom, and this is what we have in our rate table, our ratio table, 10/4, that I got from over here, 10/4. So now we know that we want to figure out how much it's going to cost for 15 cans. So our cost in dollars is our question mark. We don't know what that's going to be. Well, since over here I'm drawing my arrow to go from 10 to 15, since the number is getting bigger, you would normally have to multiply. But see, you can't multiply by any whole number to go from 10 to 15. So obviously it's going to be a fraction part or a decimal part. And sometimes with numbers that are not as easy as 10 and 15, that can get kind of messy. So what you end up doing is you want to think of a common number between them that will work for you in your favor. So it kind of you really need to know your multiplication facts pretty well to understand how to do this. You can still work it out without knowing them too well, but it just makes you think a little bit harder. So I need to think of, well, what can I do to 10 to make it easier for me to get to 15? So let me go ahead and erase my arrow over here. So the easiest thing that I can think of is using the number 5. So if I do this, if I put a 5 here, what that's telling me to do is, in order to go from 10 to 5, I would divide by 2. So what that means is I have to do the same thing to my bottom number. to go from 4 to my missing number, I have to divide by 2. So you want to make sure whatever you're doing to these numbers works for both of these numbers right over here. So 4 divided by 2 gives me 2. Now I'm not at my answer yet. So now what ends up happening is I can go easily from 5 to 15. So to go from 5 to 15, I multiplied by 3. So therefore, I need to multiply my bottom number by 3. 2 times 3 ends up giving me 6. So your answer ends up being $6. Because remember, that's our ultimate answer right there. Our ultimate question is 15 cans of corn would end up costing $6 on that one. So in this example, we had to scale down. Scale down meaning we had to make our number smaller. And then we scaled forward or scaled up, I tend to use, because then we had to make our numbers bigger. So let's look at example 4. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Okay, so if you see here, they've already started making the table for you. Actually, they completed the entire table. But there's a series of questions you do want to ask yourself when you're doing this. So for instance, your rate or your ratio ends up being 14 over 8. So 14 representing the number of hours that he's mowing, and then 8, representing the number of lawns that he's mowing. Well, it's then saying how many lawns can he do in 48 hours, or 49 hours, So the first question over here says, is there a whole number by which you can multiply 14 to get 49? The reason why they're asking that question is they're saying, well, what can you do to 14 to get to 49? Well, there isn't any whole number that you can do that. It's not going to look pretty. So therefore, this question is no. There's no whole number you could multiply 14 by to get 49. So the second part of the question is asking you, it's telling you to scale back to, so now what you want to think of is you want to use a number, so when you're scaling back, means you're going to be dividing. Whatever number you choose to divide by has to be divisible by both the 14 and the 8. Usually you're going to divide back by a 2, a 3, a 5, sometimes a 4. They're usually going to be one of those smaller numbers. Usually. That doesn't mean it's going to be, only those, but typically it's going to be, some of those numbers. So if we scale back to 2, okay, by dividing by 2. So if I take my 14 and I divide it by 2, so this guy right over here, I divide by 2. Therefore, I have to divide my 8 by 2, okay? So here's my divide by 2. 14 divided by 2 on the top is going to give me a 7. 8 divided by 2 on the bottom gives me a 4. So now I can sit there and think, well, what do I do to 7 to get 49? You multiply by 7. So what do you do to 4 to get some number? You multiply by 7 only because the top got multiplied by 7. And that's how they got the 28 over there on that one. So over here, you were going to scale back to you end up dividing by 2 and multiplying by 7 there. So Joe can end up mowing 28 lawns in 49 hours. So the scaling back and scaling forward sometimes just takes a few minutes to kind of think about, or a few, trial and error type things to make something that ends up working for you. All right, now it's your turn to try scaling all on your own. So go ahead and look at this example. A child's height measures 105 centimeters. Estimate her height in inches. So they've already set up the table. You most definitely have to scale on this one. So to give you a hint, you're going to scale down and then scale forward. All right, give it a try. All right, well, here's the final problem. Or the final answer. So the child's height ends up being, 42 inches. So you can see that I scaled down to 5, and then on the bottom to 2. So I divided both numbers by 5, and then I scaled forward by multiplying both by 21. All right, so on our last page, page 42, example 5, On her vacation, Leah exchanged $50 American and received $60 Canadian. Use a ratio table to find how many Canadian dollars she would receive for $20 American. Okay, if that sounds weird, a lot of times when you're going from one country to another, the dollar value is not the same. It's not equivalent. So sometimes you end up getting more money for your money or less money. So it does fluctuate. Right now, I believe the last I looked, the American dollar was a little bit more than the Canadian dollar, but a few years ago, the Canadian dollar was more. So anyway, so go on. So you've got your ratio here. So you've got your Canadian dollars and your American dollars. So for 60 Canadian dollars, she gets, or I'm sorry, for 50 Canadian dollars, she gets 60 Canadian dollars. So they've set the 60 on top, 50 on the bottom here. Just make sure you're keeping up with where the words are. So it wants to know how much she's going to get in Canadian dollars if she uses 20 American dollars. So you can't do anything to go from 50 to 20. So they scaled down. Here you can see what they did in this problem. Let me take away my circles. So you can see here what they did is they scaled down by dividing by 10 and they got 5. And they did that to both sides, 6 on the top. And therefore then they multiplied it by 4 to get to 20. So therefore multiply your top number by 4, and that's how they ended up with the 24. So you can see that all these problems are done basically the same way. It's just the situations tend to be a little different. All right, guys, now it's your turn to give this a try. When you come back to class, I would like for you to have page 42 done, questions 1 through 3 only. They've already drawn the tables for you to the right of each problem. Make sure on the line you do put what the final answer is. So by line, I mean this line, and this line, because it's important for you to understand what your final answer is going to be. Now, if you look at the top one, it gave you several boxes here. So what that's saying is you may have to scale down or up or down several times before you get to what you need to get to. Now, if you can take shortcuts, and by shortcuts I mean if it goes into it evenly, by all means, use that. It's not necessary for you to have that middle step. Remember from examples 1 and 2, those were ones where we didn't have to have that middle scaling step. But when you get to an example like 3 and 4, you did. All right, guys, so good luck, and we'll see you back in class. Have this done.